Hello everyone, today we're going to be learning about trailing zeros. So let's look at the problem we're trying to solve. Without doing any multiplication at all, find how many zeros are at the end of this number. So we're given 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and we have to find how many zeros are at the end of this product. But the catch is we can't multiply it out. So this seems impossible right now, so let's focus on what we can figure out from this. We can determine that this product is a factorial. And a factorial is a mathematical operation where a positive integer is multiplied by every positive integer less than it. So it's kind of like countdown multiplication. So we can tell that this is 10 factorial because we're starting with the positive integer 10 and then going to every positive integer and then multiplying it by every positive integer less than it. So I'll give you the answer for this problem. 10 factorial is equal to 3,628,800. So we see that there are 2 zeros at the end answering our question. So let's call these zeros at the end trailing zeros. But I gave you the answer for 10 factorial, but how would we find this for larger factorial operations like 20 factorial, 50 factorial, 60 factorial, 70 factorial, and so on? Well, the first thing we need to learn is where do these zeros come from? So the trailing zeros come from whenever a number is multiplied by 10 because of our base 10 number system, where every position in a number is a power of 10. So we can see this in the example of the breakdown of the number 1,250, where each place value, so essentially the ones, tens, hundreds, and thousands, is determined by the power of 10 the place is multiplied with. So we have 10 to the 0 power, which gives us the ones place, 10 to the first power, which gives us the tens place, 10 to the second power, which gives us the hundreds place, and 10 to the third power, that gives us the thousands place. Now we see that if we multiply this number by 10, we get an additional 0, and the place values of all the numbers essentially move up because we are adding on to this power of 10. So now that we saw that multiplying by 10 results in an additional 0, we can take a look at the prime factorization of 10, where we see 2 times 5 is equal to 10. So what we can see is that trailing zeros aren't just created by multiplying 10, but also by multiplying a pair of the prime factors 2 and 5, because that also gets us to 10. So now let's try and prime factorize all the numbers being multiplied in 10 factorial. And this way we can kind of see a breakdown of the prime factors and pay close attention to the 2 and 5, which we know will get us to 10. So starting with 10, we know 10 prime factorized is 2 times 5, 9 is equal to 3 times 3, 8 is equal to 2 times 2 times 2, 7 is just 7 because it's prime, 6 is 2 times 3, 5 is just 5 because it's prime, 4 is 2 times 2, 3 is just 3 because it's prime, 2 is just 2 because it's prime, and 1 is 1. So we can see that 10 factorial is equal to 2 to the 8th power times 3 to the 4th power times 5 to the 2nd power times 7. So now we want to pay close attention to our 2 and 5s and see how many 10s we can make out of them. So let's start with our first pair of 10 from a 2 times 5. So we're taking 1 2 to make our pair, which leaves us with 2 to the 7th power, and 1 5 to make this pair, which leaves us with 5 to the 1st power. So that gives us 1 10, which in turn gives us 1 trailing 0. Now we see we have enough 2 and 5s to make another pair of 2 times 5, which gets us to 10, where we have no more remaining 5s, and 2 to the 6th power, which gives us an additional 0 because this multiplies to 10. But now we see we can't make any more pairs of 2 times 5 because we've run out of 5s. And that's because multiples of 2 occur every 2 numbers, while multiples of 5 occur every 5. So what this tells us is the number of 5s that come when prime factorizing is what we need to determine the number of trailing zeros, because they are a required factor of 10, but there are fewer of them than 2s. So essentially, once you run out of 5s and there are less of them, you can't make any more products of 10. So now let's apply this to 20 factorial. So we know that we need to look for the number of times we get the prime factor 5. So what better way to do that than looking at multiples of 5, because they will, when prime factorizing them, have a factor of 5. So we look at 5. 5 is equal to 1 times 5. 10 is equal to 2 times 5. 15 is equal to 3 times 5. And 20 is equal to 4 times 5. So we see that if we look at the prime factorization of these, there are 4 5s. So because there are 4 5s, that in turn gets us 4 trailing zeros, because that means we can make at least 4 products of 10. That is all. Answer these questions in the quiz feature on YouTube. So find the trailing zeros of 75 factorial and 30 factorial, answer them in the quiz feature, and that's all from my side. Bye!